Table cone in Annex C of the National Electrical Code provides the maximum number of conductors that are permitted to be installed in a given size conduit. The conductors listed in Table cone are all the same size and do not include an equipment grounding conductor. The National Electrical Code does not specifically state whether or not an equipment grounding conductor can be included in a conduit that is filled to the maximum number of conductors allowed by Table cone. However, the National Electrical Code does require that an equipment grounding conductor be installed in every conduit that contains circuit conductors. This requirement is found in Section 250.118(10) of the National Electrical Code. Based on these two requirements, it is reasonable to conclude that an equipment grounding conductor can be included in a conduit that is filled to the maximum number of conductors allowed by Table cone, provided that the equipment grounding conductor does not exceed the fill capacity of the conduit. To illustrate, consider the case of installing four number 4 THHN conductors and a number 8 equipment grounding conductor in a 1-inch conduit. The fill calculation for this combination of conductors is 0.524 square inches, which is less than the 0.864 square inch fill capacity of a 1-inch conduit. Therefore, it is permissible to install these conductors in the 1-inch conduit. Annex C of the National Electrical Code is not enforceable code. However, the requirements in Annex C are generally considered to be good engineering practices. When determining the appropriate size conduit for a given set of conductors, several factors must be considered, including the size and number of conductors, the type of insulation on the conductors, and the fill capacity of the conduit. The National Electrical Code provides detailed guidelines for conduit fill calculations in Chapter 9 and Annex C. Firstly, determine the cross-sectional area of each conductor. This information can be found in Chapter 9, Table 5 of the National Electrical Code for various conductor sizes and insulation types. Secondly, calculate the total cross-sectional area of all conductors. Sum the individual areas of all conductors, including the equipment grounding conductor, that will be installed in the conduit. Thirdly, determine the allowable fill percentage for the conduit. The allowable fill percentage depends on the number of conductors in the conduit and is specified in Chapter 9, Table 1 of the National Electrical Code. For example, for more than 2 conductors, the allowable fill is typically 40%. Fourthly, calculate the required conduit area. Divide the total cross-sectional area of the conductors by the allowable fill percentage to determine the minimum required area of the conduit. Fifthly, select the appropriate conduit size. Refer to Chapter 9, Table 4 of the National Electrical Code to find the conduit size that has a usable area equal to or greater than the required conduit area calculated in the previous step. It is important to note that the fill calculations must comply with the National Electrical Code to ensure safe and reliable operation of the electrical system. Overfilling a conduit can lead to overheating of conductors and potential damage to the insulation, which can increase the risk of electrical faults and fires. While Annex C provides valuable guidance and examples, it is essential to understand that it is not a mandatory part of the National Electrical Code. However, following the recommendations in Annex C can help ensure that the conduit installation meets accepted industry practices and promotes a safe and efficient electrical system. In addition to the fill calculations, other factors should be considered when selecting conduit sizes. These include the need for future expansion, the presence of bends or offsets in the conduit run, and the dating of conductor ampacity due to the number of conductors in the conduit. Bends and offsets can reduce the effective fill capacity of the conduit, and dating of conductor ampacity may be necessary if the number of conductors in the conduit exceeds certain limits. Consulting with a qualified electrical engineer or inspector can help ensure that the conduit installation is compliant with all applicable codes and standards. The equipment grounding conductor plays a critical role in the safety of the electrical system. It provides a low impedance path for fault current to return to the source, which helps to quickly trip the circuit breaker or fuse and prevent electrical shock hazards. The size of the equipment grounding conductor is determined by the size of the circuit conductors, as specified in Section 250.122 of the National Electrical Code. It is essential to ensure that the equipment grounding conductor is properly sized and installed to provide effective protection against electrical faults. When installing conductors in a conduit, it is also important to consider the type of insulation on the conductors. Different types of insulation have different temperature ratings and resistance to moisture and chemicals. The type of insulation must be suitable for the specific application and environmental conditions. The National Electrical Code provides information on the allowable uses and installation requirements for various types of conductors and insulation. In summary, determining the appropriate size conduit for a given set of conductors involves several steps, including calculating the total cross-sectional area of the conductors, determining the allowable fill percentage, calculating the required conduit area, and selecting the appropriate conduit size from the National Electrical Code tables. It is also important to consider the role of the equipment grounding conductor, the type of insulation on the conductors, and any other relevant factors that may affect the safety and performance of the electrical system. While Annex C of the National Electrical Code is not enforceable code, it provides valuable guidance and examples that can help ensure compliance with accepted industry practices. Always consult with a qualified electrical engineer or inspector if you have any questions or concerns about conduit sizing or any other aspect of electrical installation. It is very important to emphasize that electrical work should only be performed by qualified and licensed individuals who are familiar with the National Electrical Code and other applicable codes and standards. Working with electricity can be dangerous, and improper installation or maintenance can lead to serious injury or death. Therefore, it is essential to prioritize safety and follow all applicable codes and regulations to protect yourself and others from electrical hazards. When planning an electrical installation, it is also important to consider the long-term needs of the system. Will there be a need for future expansion or modification? Will the system be subjected to harsh environmental conditions? These factors can influence the choice of conduit size and materials. For example, if there is a possibility of future expansion, it may be wise to install a larger conduit than is currently required to accommodate additional conductors. Similarly, if the system will be exposed to corrosive chemicals or extreme temperatures, it may be necessary to use special types of conduit and fittings that are designed to withstand these conditions. Proper planning and foresight can help ensure that the electrical system will meet the current and future needs of the facility. The National Electrical Code is updated every 3 years to reflect changes in technology and industry practices. It is important to stay up to date with the latest edition of the National Electrical Code to ensure that your electrical installations comply with the most current requirement. Many jurisdictions also have local amendments to the National Electrical Code, which may further modify or add to the National Electrical Code requirements. It is essential to be aware of these local amendments and to comply with them as well. Continuing education and training are essential for electrical professionals to stay current with the latest codes and standards. There are many organizations that offer courses and seminars on electrical topics, including the National Fire Protection Association, the International Association of Electrical Inspectors, and various trade associations. Taking advantage of these educational opportunities can help you improve your knowledge and skills and stay ahead of the curve in the electrical industry. In addition to the National Electrical Code, there are other codes and standards that may be relevant to electrical installations. These include the National Electrical Safety Code, which covers the safety of electrical supply and communication lines, and the Life Safety Code, which covers the safety of buildings and their occupants. It is important to be familiar with all applicable codes and standards to ensure that your electrical installations meet all requirements. Electrical inspections are an important part of the process of ensuring that electrical installations are safe and compliant. Electrical inspectors review plans and inspect installations to verify that they meet the requirements of the National Electrical Code and other applicable codes and standards. If an installation fails to pass inspection, the inspector will issue a notice of violation, which must be corrected before the installation can be approved. Working with a qualified electrical inspector can help you avoid costly mistakes and ensure that your electrical installations are safe and compliant. Electrical safety is a shared responsibility. Electrical professionals, building owners and occupants all have a role to play in ensuring that electrical systems are safe and reliable. By following the National Electrical Code, using qualified electrical professionals, and being aware of potential electrical hazards, we can all help prevent electrical accidents and injuries. Remember to always de-energize circuits before working on them, use appropriate personal protective equipment, and follow lockout/tagout procedures to prevent accidental energization. Electricity is a powerful and essential force in our modern world. By understanding and respecting its potential hazards, we can use it safely and effectively to power our homes, businesses, and industries.